Welcome to another. This is an Eaton Tech Talk. It's an Eaton Tech Talk. And it is a live at 5 Tech Talk. It's the first time we ever came and we've done a live at 5. So I'm getting things set up here. We're going to talk about 70B. Hopefully you're ready for a deep dive. I'm hoping you are. I am going to accept. So Abdul Hamid Kayal, engineering manager from Turkey, from Eaton. Thank you for joining. I just brought you a part of the network. So you are now a person who is in my LinkedIn network. All right, so we are going to talk about NFPA 70B. So here's what I need you to do. I need you to get your, let me close this out because this is going to be distracting. So I need you to get your NFPA link out and get your NFPA link out. You're going to open up the latest edition of NFPA 70B for maintenance. And I want you to open NFPA 70E, Edward, as well for safe working practices. Hey, Nihad El Sharif, you're in Cairo. Good thing, buddy. Hopefully all's well. Say hello to mom for me. Make sure you tell her when I'm in Cairo, I'm going to need to. Her and I are going to go to. We're gonna have to go to the pyramids. I want to get a selfie with her. So hopefully you'll be there. I know you're not going to be there, but you never know. So I'm drinking my coffee. It's 5 o'clock. I've got my coffee. That means we're in for the long haul on 70B. And I can see comments. Hey, Ryan Jackson in the house. Excellent. All right. Okay, I'm just making sure I got everything set here. So get your NFPA link open to for 70B and 70E as well, because here's what I'm going to do is I want to walk through some examples. And I've done this on a few other channels. IAEI, we went through and did panel boards. I believe we did panel boards. We did a few others, examples. So, hey, George, Corey, thanks. Hey, Canada in the house, eh? Good thing. Thank you, sir, for joining in. We've got Canada represented. We've got Ryan. And Ryan, I think you're probably out there in, was it Utah, I believe? And Nihad is in Cairo, Egypt. Hopefully we'll get our friend from Japan who said they were going to be on yesterday. And see, we got, hopefully we'll have Japan, and hopefully we'll have Colombia, South America represented. True international station. All right, so 70B. Why are we talking about 70B? It moved to a standard. Dadgummit. It moved to a standard, and oh, there we go. I told her that unfortunately I don't think I will be here. I know, man, Nihad, what are we gonna do? You got your iced tea glass full and ready. Florida checking in. That is just too funny. Got your iced tea. Excellent. I have to go into this and give me a second. View. Slide master, I got to do that. I just went through and deleted all of this. So NFPA 70B is our point of discussion right now, and I am ready. Just give me a second to seems like everybody's interested in 70B these days, and my iPad just locked up on me. There we go, X. And I got to go to File. All right. Get back over to PowerPoint. There we go. How do I refresh? Okay, so let me just fix this. NFPA 70B. Let me delete that. Delete. And come back over here and make sure that I didn't delete it here. Keep and save and close. And then I got to come back over here to files. And we got Ryan Jackson. Hi, Ryan. Okay, excellent. All right, 70B. All right, here we go. So this is much better. So 70B, maintenance. If you are following along in, I would say open up 70E in your, I wonder if I can do this. Hold on. So if you open up 70E, I'm going to do this right here. Safari. Right, so if you are thinking about the standards and out there on NFPA's website, if you, I basically have NFPA 70B open here, but you can go to any page in NFPA, come up here to the top left-hand side, which you can't, it's right up there. You see it? Right up there, it says NFPA link. You click on NFPA link, it will bring up link. You will log in, and I use face identification, and there she blows. So this is your interface for NFPA link. You'll click on 70B, or you can click on 70E. Let's do that, and let's search for maintenance in 70E. And I'm going to have to fix my screen, so give me a second. Display. So let's do this. I'm going to do studio mode. I'm going to come over to display. And I'm going to fix my display. Watch this. It'll magically just appear. There it is. Do you see that? Here we go. That should be fine. All right. Get that back to out of studio mode. So there we go. So we hit maintenance and we hit all of NFPA 70E. We hit search. There we go. These are all of the areas in NFPA 70E where maintenance, there are 6 pages of requirements. You got chapter 2. You have an informative annex, got condition of maintenance, maintenance history is in informative annex S, 205, article 205. Whoa. Not sure why I can't get to that. There it is. Oh, I see what's going on. Let me do this. There we go. I'll click on 5. There's your 90.3 workplaces covered, safety-related maintenance requirements. So NFPA 70E has many areas where you have requirements for maintenance requirements, and exactly 215 times in the NEC, 45 times in 70E, and 159 times in NFPA 99, and we could go on. So, excuse me, if you search NFPA 70E for maintenance, and I'll give you some examples, chapter 2 is titled Safety Related Maintenance Requirements. Now, here's where my gut's telling me is that chapter 2 of 70E, which is titled Safety Related Maintenance Requirements, the next cycle on 70E, in my humble opinion, and remember, everything on my channel, it's my opinion. It's not the opinion of anybody else. It's not the opinion of Eaton, NFPA. I sit on the NFPA 70B, but what I say is not of the opinion of anybody else on NFPA 70B, the committee or NFPA. What comes out of here start it up here. And sometimes it doesn't start up here, it just comes out there. So, but in any case, question everything you hear and everything you see. Do your own homework. So chapter 2 is titled Safety Related Maintenance Requirements. And if you look at how NFPA 70E is organized, you have the introduction in chapter 2, you have general requirements for maintenance. Article 210 is substations, switchgears, assemblies, switchboards, panel boards. 215 is premises wiring. 220 is controller, equipment, etc. But I would argue that maintenance probably doesn't belong in 70E. And I think that it probably would be a pretty doggone good public input to look at chapter 2 and really ask yourself the question, what maintenance, safety-related maintenance requirements are in chapter 2 that are specific to 70E and aren't related and already covered in 70B to the nth degree. So the reason we're talking about this and the reason of the importance of talking about maintenance in 70B is because you can't have an effective safety program if you don't have a good, effective maintenance program. It's required in 70E. So if I go to chapter 1, if I search chapter 1 for the word maintenance, you'll find it in 110.3C in 70E. Remember, 110 is your electrical safety program. 110.3 is titled Electrical Safety Program. 110.3 has A, general requirements, B, inspection requirements, C is condition of maintenance, and it says the electrical safety program shall include elements that consider condition of maintenance of electrical equipment and systems. And you have to ask yourself, how are you meeting that requirement? Ryan, you brought up a very good point. Maintenance and the NEC. So, got my latest copy of the book. Here's the issue, Ryan. Here's what I think. I think that the motivation to put requirements in the NEC may have been because 70B was not a standard. 70B was a recommended practice. And the other motivation to put something in the National Electrical Code is the hook, right? 70B isn't enforced. It's not mandated. And now if you are a government lab, 70B is mandated. They use 70B. In fact, they enforced 70B when it was a recommended practice, because what is the principle of 70B? 70B tells us you have to have a maintenance plan, and they give you the ingredients for a maintenance plan. 70E, for safe work practices, tells us we have to have a safety plan, and it gives us the ingredients for the safety plan. 70E is not mandated by law. 70B isn't mandated by law. But they require us to put procedures in place. Now, I have a Facebook user here that says, NFPA, excuse me, does that document include examples of MOPs? So these operating procedures, they give you, I'll tell you, I'm going to lay out how 70B is laid out. Just give me a second. And then hopefully Mr. Facebook user will look at this. I'm getting Ryan, I'm getting on the edge of my seat here. I'm getting motivated here. So the key thing to remember is, in my opinion, and I'm not disagreeing with you, Ryan. I think we overstep our boundaries in the National Electrical Code in some cases. I think it's fair in the NEC to say you shall perform maintenance, or I don't know. I'm really struggling with maintenance in the NEC. I understand why it's there. They need the hook. The NEC is adopted into law in jurisdictions in the United States, and you need the hook to mandate maintenance. And if you have some areas, and I think we have it in 700, if I'm not mistaken, Article 700. I almost spilt my coffee. Article 700 has some maintenance requirements in, give me a second here, and I should search for it, but I'm not. Reconditioned equipment, there it is, test and maintenance. So in 700.3, they talk about testing periodically. And then in 700.3 Charlie, for maintenance, it says emergency system equipment shall be maintained in accordance with manufacturer's instructions and industry standards. And I know that's hard to enforce. It's an installation requirement. How do we enforce maintenance requirements in 70? I'm on that ledge with you, Randy, or Ryan, and I understand why it's there. I know it's hard because we all want it to be enforced, and that's the big dilemma, is how do we get people to enforce electrical maintenance? So we have the requirements in 110.3C and a few other areas in the NEC, in 70E, and we have areas in the National Electrical Code that speaks to maintenance as well. And I think that we should take a look at a lot of this as we move forward to say what belongs there and what doesn't. All right, so there are provisions in 700, but also in 110. That's right. That's right. And I'll tell you why in 110.17, I'll tell you the story there. So 110.17, for all of you out there in Tube land, Facebook land, LinkedIn land, I don't know if I'm alive on Instagram, Twitter land, I'm alive on Twitter too, so, or now it's called X. I think it's called X now. I don't know, I just saw that somewhere. So 110.17 is titled Servicing and Maintenance of Equipment. And Ryan, we added a definition of servicing to help people understand what does servicing mean, right? So servicing is defined as, and that's a new term that is defined in the National Electrical Code. It is called servicing, service drop, service equipment, servicing. And I highlighted it in yellow, and I didn't read it, didn't stick out. Process of following a manufacturer's set of instructions or applicable industry standards to analyze, adjust, or perform prescribed actions upon equipment with the intention to preserve or restore the operational performance of the equipment. I would say servicing is very similar to maintenance. And quite frankly, so here's the hook, Ryan. If you are going to maintain your equipment, you need to understand, when are you servicing the equipment to bring it and restore it back to working condition and meeting the definition of servicing, and when are you reconditioning it? So because there are certain requirements that fall that come in play whenever you are reconditioning. As you very well know, you have to remove the manufacturer's label, you have to put your own name on it, you have to remove the UL listing mark, and in some cases it may be required to be listed. But remember, who's enforcing this? And I know a lot of individuals will say, tell me the AHJ who's going to follow this book and when you're performing maintenance, right? So here's the issue. The AHJ, in many cases, is a plant manager. And there's no permit pulled. There's no government organization coming in doing an inspection. But that doesn't mean that the AHJ, the facility plant manager or whomever the AHJ is in that facility, that doesn't mean they don't have to follow this book. So I don't need to say I only have requirements in the NEC that are going to be inspected by a third-party organization. I don't need that because the AHJ could be me, right? So if I'm in my residential dwelling unit, for where I live, they inspect the service. The inspectors do not come inside the front door, even in new construction. I'm not required to pull a permit if I add a circuit inside my house. But I'm the AHJ here because this is my house. I'm going to hire a professional. I'm going to hire somebody to come in and say, add that circuit. And I'm going to tell that individual, you're going to follow this book. And I could hire a third-party inspector if I wanted to. I could call Jack Jameson down there in Morgantown, invite him to the house, and invite him to dinner and say, hey, let's go take a look downstairs at this circuit that's added and tell me if my electrician is doing the right job. So I don't necessarily have to, I don't have to pull a permit to have requirements in here. Again, it's the fence thing. So the challenge with 70B is enforcement. And in many cases, we're going to enforce 70B because we are trying to enforce 70E. And the reason we're doing that is because we want to make sure our electrical workers are safe, and we don't want to have an OSHA violation put us out of business. All right. All right. So having said all that, let's talk a little bit about how the standard is laid out. I'm not sure. How do I see comments on LinkedIn? Let's talk a little bit about, I'm not sure where that came from. All right. So, oh, I see. All right. So I'm looking, I got my LinkedIn open so that I can see comments on LinkedIn. All righty. So let's do this. Let's talk about how NFPA 70B is laid out. You have various chapters. We've got chapter 1 is administration. This is where you're going to find the scope for NFPA 70B, the purpose of NFPA 70B, the application, the equivalency, units of measure. And keep in mind, this is also where you're going to find that the scope of the document, the scope is to cover preventive maintenance, electrical, electronic, and communications systems and equipment. The purpose is to provide requirements for maintenance, to provide practical safeguard of persons and property. So I can employ, I can justify maintenance not because it's going to save a life, but because it's going to prevent property damage. Or I could make the argument that if I perform maintenance, I'm going to avoid downtime and cost my business money. Right? Every minute counts. And processes from the risk associated with failure, breakdown, or malfunction, and means to establish a condition of maintenance of electrical equipment and systems for safety and reliability. Okay, so reliability is in there, so it's not just about safety. And we got Robert from Omaha. Yes, Robert, you remind me every time we talk how valued, and you make me feel valuable. So thank you, Robert. I can always say that I do this because you keep encouraging me. All right, so you're asking, why did they remove Annex B? How to instruct portion, manual of style, Annex B. Annex B is suggestions for inclusions in a walkthrough inspection checklist is there. If we want to see what other additions, open in a new tab, I'm going to go to an older version and see what you're talking about there. I'm going to look at the 2019. Annex B was how to instruct. Okay, I gotcha. How to instruct. Oh, that's talking about training. Interesting. Well, annex material, we can put just about anything that we want in annex material. I can't remember the reason why we did not include Annex B. I wouldn't say it's because of a style manual. Annex B, and you know what? I look forward to your public input because I'm not sure. I mean, it's not in any of the it's not in the current annex material. So we dropped that one off. I'm not sure why. I don't have a good answer for that. Because it was a complete rewrite. Here's the issue. Because it was a complete rewrite, little details like that may not be able to be discovered. All right, the application. The standard applies to maintenance of electrical, electronic communication systems and equipment. And again, it's looking at industrial plants, institutional, commercial buildings, and large multifamily residential complexes. What you're not going to see in here are your dwelling units. Your single family homes aren't covered in this, but I'll say that a lot of the maintenance, if you look at maintenance on receptacles and equipment that you have in a residential dwelling unit, I can't see why you would not be able to leverage this information to determine what you need to do inside of a dwelling unit. But this does not cover a dwelling unit. It doesn't cover consumer appliances and equipment for the home. So you're not going to take a toaster and look at 70B and determine what the proper maintenance is of a toaster. It is what it is. All right. Nothing in the standard is intended to prevent the use of systems, methods, or devices of equivalent or superior quality. And then they talk about units of measure. So that's basically chapter 1 is all of your administrative requirements, just sets the stage, so to speak, for the document itself. Chapter 2 has all of our reference publications. You'll see all of the NFPA publications, which there are none in there. It's all reserved. And honestly, they have references for extracted material from 70 and 70E. And they have I love this, Robert. They have the Merriam-Webster's Collegiate Dictionary, 11th edition, and hopefully you got your copy like I got mine. 11th edition. This baby hasn't been cracked, but I have a copy just in case. So that's chapter 2. And what that means is if you have a term that's used in this standard and it's not defined in chapter 3, then you use this and it says Merriam-Webster's Collegiate Dictionary 11th edition. So 11th edition, that's what you need to complement this. Now, terms can also be taken from building codes. I would fall back on the building code if I'm trying to understand an area or whatnot. All right. I do. Okay. Let's look at now. Another question you might have on your mind is why is definitions in chapter 3 and not in Article 100? Well, the reason for that is because NFPA 70B isn't governed by the NEC style manual. It's governed by this document, which is the regulations governing the development of NFPA standards. So 70B is laid out differently than the National Electrical Code. And you can get a copy of this document. I'll tell you where you can get a copy of this document. If you go to www.nfpa.org let's just go to nfpa.org and you go to codes and standards and you go to under standards development, you go to regulations and policies. Then you have the regulations governing the development of standards. That tells you who can sit on a committee, how many people on the committee, all that jazz. Guide of conduct for participants, making sure you're acting nice. The technical meeting convention rules, that's the annual meeting. You scroll down to manual of style for technical committee documents. That's the document that you need. This is your manual of style. You have your codes and standards, what's covered, front matter, table of contents, introduction. Look at this. Here's your administrative chapters. Administration, chapter 2 is reference publication, chapter 3 is definitions. So this is the reference that you should be using to understand how this document is laid out, right? So you have the scope, the purpose, application, all that good stuff. So the rules that we use to create this document are different. That's why we go to chapter 3 for definitions. So if you don't have a defined term in chapter 3, then you're looking at maybe the building code or Merriam-Webster. Now, chapter 4 are your general requirements. Okay. The first thing in chapter 4, the very first item in chapter 4 tells us that that the electrical equipment has to be maintained in accordance with manufacturer's instructions and applicable codes and standards. So, what that means is, if you have a product that you're going to be performing maintenance on, you're going to want to go to the manufacturer's recommended guidance or recommended maintenance schedules. So if you have a car, for example, then you're going to want to make sure that I'm just relating this to what we all know. We have a vehicle. We open up the book from the manufacturer of that vehicle. It'll tell us how often we need to change the oil, when we need to change the transmission fluids, how often to check the brakes, all that stuff, right? So what 70B is telling you is if you have a motor control center, and it's who would buy anything other than an Eaton motor control center? I don't know. But if you had an Eaton motor control center, you would go to Eaton, you would go to the manufacturer of that motor control center and say, hey, what's the maintenance schedule? What should I do? Panel boards, switchboards, circuit breakers, fuses, fusible disconnect switches, all of those electrical components are going to pretty much, they should all have maintenance schedules that you should be following. Now, the other thing in 4.1, what it tells you is that 70B is not intended to duplicate or supersede manufacturer's instructions. Now, here's where the gray area is. What happens if you look at, you download Eaton's maintenance schedule for, I don't know, a Van Ducky. Okay, you got this new Van Ducky, and it's supposed to work wonders for your plant. It's going to increase your performance and your throughput, all that jazz. And the manufacturer's instructions for that Van Ducky says you need to turn it on and off once a month. Well, what about the terminations and the connections? What about the other aspects of 70B that are required that the manufacturer's instructions don't provide any guidance on? That's where you fall back on 70B more heavily, because the manufacturer's instructions don't include some of those other details, right? You may talk about, well, how often do I need to clean it? Do I need to wipe it down? Do I need to keep it free from dust? All these other great things. 70B can fill those gaps for you. But remember, the general requirements, chapter 4, 4.2 tells us that we need to create an electrical maintenance program. It tells us that 70B doesn't supersede manufacturer's instructions. It can supplement manufacturers. Doesn't say it doesn't supplement, doesn't duplicate or supersede it, but it can help you fill those gaps. That it tells you that if you don't have the manufacturer's instructions, the equipment shall be maintained in accordance with the industry consensus standards, and voila, you're looking at one, right? 70B. Now, if you scroll down to 4.2, 4.2 tells us, look, you need to have a maintenance program, an EMP. The owner, the equipment owner, shall implement and document an overall EMP. It's not the contractor. It's not. It's the owner, right? The owner of the equipment, whoever owns that equipment. So if my house was a manufacturing facility, I own the house, I own the equipment. I would have to create an electrical maintenance program. And I'm sure that if I had an electrician come into my facility and I hired an electrician to do something, to do some work, add a piece of switchgear, a motor control center, do whatever it is, they should be sitting down with me saying, hey, I want to see your maintenance program. And have you pulled maintenance? What's the maintenance on the equipment that is going to be providing my arc flash reduction? And are your one-line diagrams up to date? Because I need to figure out my lockout tagout to establish an electrically safe work condition, right? So as the owner, I need to make sure that I have all of that information updated based upon my electrical maintenance program, which it tells us there's elements of the electrical maintenance program. It says the EMP shall include elements to verify that the electrical equipment or systems have been inspected to comply with the applicable installation codes. So installation codes. So if I may not have had to have pulled a permit to get a third-party inspection, but as the owner, it's my responsibility to make sure I'm following this book. Now, I could argue I'm not going to follow the 2023 code. I'm going to follow the 1971 code because this house was built, or this manufacturing facility was built in 1971. That's something you'll have to address on a case-by-case basis. But remember, you're going to have to address the installation requirements because it tells you in 4.2.2.1, the EMP shall include elements to verify that electrical equipment or systems have been inspected to comply with applicable installation codes and standards. That the equipment specific maintenance tasks have been developed utilizing information gathered during that inspection. So you're going to be looking to make sure you're following this book. You're going to make sure which this book tells you that it has to be installed per the manufacturer's instructions. You're going to be looking at that equipment at the time that you're inspecting it, and you're going to be determining the equipment specific maintenance tasks, which will be based upon the condition of maintenance, which is the next item, 4.2.3, condition of maintenance. You have to consider the current condition of maintenance. So if you have a facility and you've never performed maintenance in your facility, you're going to have a task. I mean, you're going to have a considerable effort. I think the first thing you need to do is ascertain the condition of maintenance and inspect all of your equipment. So you're going to need to probably create a spreadsheet of all of the equipment in your facility, a one-line diagram of the power distribution system in your facility. And you're going to have to ascertain the condition of maintenance. And I would argue that you're also going to have to consider other aspects of that equipment, where it's located. So condition can be dependent upon the environment within which it's located, the level of use or abuse that it receives, and you'll have to ascertain any of the potential risks to not only the personnel that is going to be working on that equipment, but also the risks to those around the equipment and to your facility. Even if you have a piece of equipment, you'll say, look, if that equipment burns down, I will not hurt a single individual in this structure. But if that piece of equipment burns down, I lose $1 million an hour. You need to consider that, right? So from a safety perspective, you don't, but from an equipment protection, from a equipment protection, from a process protection, and that's might be where the justification for your efforts come from. Remember, I had I had a discussion with an individual at an organization, contracting firm, that, excuse me, I had a discussion with a person at an organization, a contracting firm that did a great job of getting help, financial help, for their safety plan. And I asked them, how do you do this? I mean, you need to get support from upstream, and you need to get the agreement from everybody on the job sites to follow all of these rules. And you know what he told me? He said that there's two ways. He says you have to understand your audience. He goes, when I talk to my people who are on the job sites, I talk to them about going home to your family. I talk to them about keeping those digits, right? All 10 of them. I talk to them about their livelihood and about how lost hours can impact their financials at home. He goes, but when he talks to senior leadership to gain support, he's talking about the financial impact to the business, because he needs to justify his efforts and his resources that he's asking for, which costs money. And what the management looks at is the financials, but what his people are looking at are the human aspects of it. So, I mean, it sounds bad that money talks, but that's the world we live in. So we have to take that under consideration, that you're going to have to explain the human aspect of what you're focused on, but you do need to justify the costs associated with this as well. So in any case, understanding the financial impact to your processes is important as well. Is condition of maintenance the same as operational or operating condition? Robert, I think that's you. Yeah, Robert. I think operating condition could be the condition of maintenance. I could argue that. Functionality, is it performing? Is it not performing? It really does depend. It depends. So, all right, so I got to go back over. So let's get back over to 70B. So what I'm doing is I'm walking down through chapter 4, right? So you got condition of maintenance, you have EMP principles, electrical maintenance program, right? So that your EMP is your electrical maintenance program, your principles. So in that area is where we talk about you have to have an electrical safety program that addresses the conditions of maintenance. And Robert, what my thoughts are there is, if you have a piece of equipment that is visibly, say you have a piece of equipment that has never been looked at in 20 years, or a switch, safety disconnect switch, it's never been operated in 20 years, that it's at a high risk. Identification of personnel responsible for implementing each element of the you can't have a maintenance program and not identify resources necessary to implement All right, that has to be as part of one of your electrical maintenance program. You have to do a survey and analysis of the electrical equipment to determine the maintenance requirements and priorities. So one of the steps in your journey, if you have a facility that you don't have an electrical maintenance program for, one of the steps in your journey is to identify all of that equipment that you need to look at, ascertain its condition of maintenance, find out what, if you have manufacturer recommended maintenance schedules or programs or activities that need to be performed. And then you need to understand the criticality of that equipment, right? You need to understand, will it take down my process? Is it in an area where it exposes guests? You might have a piece of electrical equipment outside that looks terrible, that needs maintenance, maintained, that you don't know, if I have an event there, I could hurt somebody who's maybe not even a part of your organization. Could be a visitor, right? Could be the lawn care individuals. Could be other people that you've hired to do things that aren't electrical related at all. You need to ascertain the condition, the location, the risk associated with all of that equipment. The best way to do this is to create a spreadsheet. One way to do that is to create a spreadsheet. Probably the best way to do that is to hire an organization to come in and do that for you. But in any case, someone is going to have to walk down that facility. You have to develop and document a plan of procedures for all of the different pieces of equipment, and they will vary. It's one thing to say I have, maybe you have 175 kVA transformers in your facility, and maybe you have 1,000 GFCI receptacles. Maybe you have 2 motor control centers. Can you treat the motor control centers and those product groups the same? Maybe. If those 2 motor control centers come from 2 different manufacturers, well, they may have different maintenance plans, or you can fall back on 70B. Plan of inspections and servicing and any tests, maintenance equipment and personnel documentation and records. You have to have policies in place. You have to implement and take corrective measures based on collected data. You have to incorporate design for maintainability in your electrical installations. Now, there's a concept. That's more of a design aspect. I mean, it is a design. It says process for incorporating design for maintainability. What does that mean? You might need working space. You might, for example, let's say you have lighting that takes a crane to replace. If you put a luminaire or you put a lamp and you lamp it with, say, LED technology, you can reduce your maintenance procedures by selecting a technology that has a longer process time, right? So if I need scaffolding in my facility, I have a warehouse and I have scaffolding that I need to put up to change light bulbs. I have to relamp things. Say my lights burn out every now and then monthly. I have, X amount of lights. Well, you're going to have to go up there and relamp things. And while you're up there, you're performing maintenance, etc., looking at things, cleaning things. But if you went with a technology that reduced the amount of times you had to get on scaffolding, reduced the amount of inventory you have made changes to reduce the maintenance requirements. You reduce putting your maintenance personnel's lives at risk, because anytime you send them up on scaffolding or put them on ladders, ladders are like number one OSHA, number one accident. If you look at the OSHA databases, they'll tell you people are falling off of ladders. They're harnessing, the fall harnessing, all that good stuff. A program review and revision process. So you have your EMP principles, then you have your EMP controls. You have to have ways that you're measuring and monitoring all of those principles that you've got in place. You have to have incident investigations. You need to audit those and document those incidents, and then understand how those incidents impact your maintenance plans. You have to have a maintenance plan audit every not to exceed every 5 years. You saw language like that on system studies in 70E, and then you have your what is it in 4.3, which I don't know if I have that here. Now 4.3 talks about personnel. It talks about you have to have a coordinator. You have to have somebody responsible for your maintenance plan. You have to have maintenance EMP, electrical maintenance plan program duties that are assigned to qualified people. Now, what is a qualified person? That's a whole nother area of discussion, but you need to have your individuals trained not on how to install products, but how to maintain products. Two different things. You have to have electrical maintenance training, and there's a lot to training. I can just tell you, that like when you buy a piece of equipment today is much more complicated than what it's used to be, which is a good and a bad thing. The good thing is, because it is more technical and complicated, you might be able to get information out of that equipment to help you formulate a maintenance plan that is streamlined and more economical. Now, let's talk about that for a second, because we do have recognition in here that in chapter 9, maintenance intervals, we recognize in chapter 9 that if you have continuous monitoring or predictive techniques, you can use those to determine your maintenance intervals. So if you have equipment that can provide you information, for example, let's say you are monitoring all of the circuit breakers in your facility, and let's say that you could easily identify which circuit breakers have been turned on and off within the last year. Because remember, you may say, look, the maintenance tells me I need to turn the breaker on and off, cycle that breaker annually. If I can tell you, based upon technology, all of the breakers that have been turned on and off within the last 12 months, that would save you from having to turn those breakers on and off again, because you would have documentation that demonstrates they have been cycled. That portion of your maintenance plan has already been completed. No need to do it twice. So now what does that do? If you have 1,000 breakers and I tell you 800 of your breakers have been cycled within the last 12 months, then you only have 200 to focus on instead of 1,000. So I've reduced your workload. I've streamlined your maintenance, and you're not necessarily adjusting your frequency, because you're just recognizing that a portion of the maintenance for those products have already been completed. So technology is moving at a fast pace, but we can leverage technology to make what we do more efficient, if that makes sense. All right. Let's do this. Okay, so give me 1 second here. I want to make sure. Whoop. All right. So I'm clicking on something, and anyway. All right. So, excuse me. You've got your maintenance frequency. You can adjust those based upon technology. So even though your equipment is getting more complicated, you can adjust and use that technology to streamline your maintenance plan. Let's take a look. We're still in chapter 4. You've got your survey, you've got your planned inspections. You need to record your failure history, your inspection history, the condition, any operating environment changes, and you might be able to get that information from your maintenance plans. I mean, from your audits and from the activity or from the technology. You might be able to see what the humidity is and what the what the temperatures have been for that equipment. All right, Robert's got something. What do you got going on, Robert? Training is more than reading a manual or watching a video. It involves knowledge and skill. Absolutely. Application of knowledge. You're absolutely right. And so Robert, to your point, you'll want to work with the manufacturers of whomever's equipment that they have that you're buying and work with them. In some cases, you might be able to go to their facility, maybe before it ships, and get your maintenance personnel engaged with that equipment before it gets on site to ask the manufacturer questions about proper maintenance. So keep that in mind. You have your acceptance test reports. You have your impact of additions and rework to retrofitting equipment cleaning. And so these are all aspects that are important to be a part of an electrical maintenance program. Remember, 70B and 70E, they tell you the ingredients for your maintenance plan. But you need to create a maintenance plan that is unique to your facility, because your facility will have different pieces of equipment. It will have unique pieces of equipment, possibly to processes, industrial control panels that you have purchased to perform a function maybe in a manufacturing process or an alarming system, whatever it is, could be unique to only your facility. You're going to use the principles here to get that done. Okay, so let's take a look. Now we're going to go to chapter 5. I already talked about chapter 5. Chapter 5 is personnel safety, in my opinion. And well, this is what we did. We talked about maintenance in 70E, but what we did in chapter 5 for personnel safety, we just said, look, you need to make sure that electrical maintenance is performed by qualified people, and you should follow the applicable state, federal, or local codes and standards to identify hazards and reduce associated risks. So personnel safety is going to be driven by 70E. And 70E is your safe work practices. And you're working if you're maintaining, you're working if you're if in any work you're doing for whatever reason, whether you're installing, you're modifying, you're engaging with equipment for operations reasons, you're following 70E. It would not be appropriate in 70B to put safe work practices. So we did not put that in 70B. All right, so chapter 6 addresses your power system studies. This is your one-line diagram. This is your load flow study. This is your short circuit and coordination study. I made sure, it was important for me to make sure that the one-line diagram was included here. So chapter 6 is titled Single Line Diagrams and Systems Studies. So you're going to want to keep all of these updated. They gave us some guidance on how important and recognizes how important your one-line diagram and other aspects for the power system is for safe work practices. So you're going to make key decisions based off of this information, and you need to have these completed. So if you're a power systems analysis guy or gal out there, your single line diagrams shall be maintained in accordance with this chapter. Up-to-date single line diagrams shall be the primary reference for systems studies. Single line diagrams shall be maintained in a legible condition, shall be kept accurate, You need to indicate the date of last revision on the diagrams. And when single line diagrams are not available, the facility or equipment owner shall be responsible for providing an equally effective means of obtaining the necessary information. I argued against that. I wanted to mandate that you need a one-line diagram, period. And it needs to be updated. But there was pushback. And so they left this language in that just basically says, if you don't have a single line diagram, you the owner, the facility or equipment owner, has to be responsible for providing equally effective means of being able to get the necessary information. So lockout, tagout, and I'll tell you what, it can be very difficult. If it's not a one-line diagram, I don't know how you're going to get that done. Short circuit studies. So if you do short circuit studies, you need to have accurate information based upon an accurate one-line diagram. You have to make changes when changes occur in the electrical distribution system that could affect the results of the study. The short circuit study has to be reviewed for accuracy, not in excess of 5 years. So either you're going to, every time you make changes to your facility, but every 5 years, you're going to have to brush the dust off and make sure it's still accurate. And the most recent study has to be made available to the EMP coordinator. So whoever is coordinating your maintenance is going to have access to that day, to this study. And then it has to be updated when it's updated, an electrical equipment rating evaluation. So I had a question come in. The gentleman called me and said, Tom, when you do an arc flash or a short circuit study or a coordination study, if you're going to do a coordination study or an arc flash analysis, you need to have a short circuit study. His question was, when you do your short circuit study, should you do an equipment evaluation? What that means is, do you compare the interrupting ratings of overcurrent devices with the available fault current? Do you compare the short circuit current ratings of those of the equipment with the overcurrent with the available fault current? And I thought that was an odd question. I was like, well, of course you would. I mean, you can't do an arc flash analysis. I wouldn't want to do an arc flash analysis based upon equipment that's being over duty. But this individual who called me said that was actually debated, and they don't do an equipment evaluation for SCCR or interrupting ratings when they have those fault currents. You got to do that. Who determines equally effective? Oh, that's exactly right, Robert. How now what you might do, Robert, is you might say, look, for lockout tagout, you might say that you maintain a list for all of the equipment that effectively identifies the location of the upstream disconnects to establish an electrically safe work condition. You could do that. That might be an effective means to say, if that's your goal, if you're just doing it for lockout tagout, that's the only reason you're doing a one-line diagram, you could say an effective means could be that every piece of equipment has an identified location for the disconnecting means in a table format. All you need to do is go to this document, go over to whatever page, identify the equipment you're going to lock and tag out, you want to do work on to establish an electrically safe work condition, look over at column B and it tells you exactly where the disconnect is. That could be an effective way to get that aspect done, but it's really task oriented and what you're using it for. If you're using the one-line diagram to do your selective coordination study, that might not be effective. And the one-line diagram is going to give you the conductors, sizes, and all of that good stuff to do your short circuit study. So it depends on exactly what you're trying to achieve to know whether or not it's equally effective. But I agree with your statement, your comment or your question. I mean, that is a very good question. That if somebody said, "I'm not going to do a one-line diagram, I'm going to do this instead," how do I know it's equally effective? Your coordination studies, again, there's the 5-year number. You need to provide it to the EMP coordinator, and you need to update it when changes occur. And when it is updated, you're going to have to get it reviewed and verified. And then you have your load flow. There's your 5 years, your reliability studies, 5 years, your incident energy, 5 years, EMP, all that good stuff. So chapter 6, if you do power systems analysis, if you have customers who you do studies for, this you could leverage NFPA 70B to say, look, we need to get this updated. It's been 5 years. We're going to come in and maybe the update is quick and easy. You never know. You'll solicit the utilities for any changes. If no changes occurred in the plant, you can go back through your study, make sure the condition of maintenance is good, make sure the one-line diagrams are updated, put new dates on them, all that good stuff, just to say, look, we looked at all of this. All right, chapter 7. What are we on now? We're at an hour. So chapter 7, we're into fundamental tests. Here's what I'll tell you. 7 and 8. 7 and 8. 7 covers, if you just look at, these are your chapters 1 through 10. Chapter 7 and chapter 8 deal with the fundamental tests and your field testing and test methods. So your fundamental tests include the tests that you're going to do for terminations, right? Torque. There's different ways to test. There's different ways to verify a proper termination. You can use infrared, and if you go to infrared thermography in 7.4, Robert says the 5 years is a maximum. Could do it every year. That's exactly right. You could make and if you have a small facility, Robert, I would say an annual review might be very easy. In fact, if you do it annually, I could say probably, it's like, and this, I'm a bad offender of this, expense reports. If you wait too long to do an expense report, if you wait till the end of the month, you could have a stack of receipts like this, and then you got to go through, and it takes you a long time. But if you did it every week, and said, I'm going to submit an expense report every week, you could probably get that done pretty doggone quick. And the overall time to get everything done is in little bites. So you could elect on an annual basis to update your studies based upon changes that occurred that year. And if no changes occurred, then you don't necessarily have to do much, but you at least will have thought about it, right? So doing things annually might not be a bad idea. All right, so thermography. Let's go back to infrared. So when we were talking thermography, I had an individual call me and say that he hired a group to do thermography at a facility. And they got back to him. So he got an order to do thermography study for a facility. Instead of doing it himself, he farmed it out, hired another group. They gave him a quote. They implemented, and they came back pretty doggone quick. And he said, how did you get this done so fast? He's like, how'd you get them to you'd have to take all of those dead fronts off and take all that equipment apart. You'd have to dress up. And I mean, just knowing how many pieces of equipment you had to look at, and the process of taking the covers off, dressing, right, for the hazards, taking the covers off, doing your thermography, and then putting the covers back on again, and then, getting back to normal daily wear. that had to be a process. How did you get it done so quick? And he says, oh, we never take the covers off. And then the next question was, oh, they have IR windows. And he's like, no, they don't have any IR windows. We just look at the outside of the enclosure, which is not how you do thermography. You need to have access to the terminations. Now, there are many, many innovative ways that you can and I'm going to try to find a picture here. There are many innovative ways that you can access or provide visual inspection portals to equipment, even residential or panel boards. You know, they put infrared windows in equipment, and I know I have a good example here. Here we go, right here. And let me hit pause. Well, let's do this. All right, so this is a video of, I believe it's a panel board that has these, the trough actually has I'm looking for, where's it at? Here it is. So you have the nice door, and you have access to the terminations, and you can perform your infrared thermography. Then there's larger windows where you can perform thermography through these honeycombed type of panels, so you have good visibility. Yeah, you don't have to expose your electrical worker, but you know, are these standard? No. Are they required by code? No. Do I wish I had some of this? And Iris is the manufacturer of this type of equipment, but this technology is available. But in this case of this example, I'm telling you that the customer did not have access to this, and all they did was look at the outside of the equipment. So what we did in 7.4 for infrared thermography, we said that you shall be used when required to verify temperature differences, a delta T, for similar electrical equipment under similar loading, because loading is important, comparison between electrical components and ambient air temperatures. So one aspect is, you know, you have to understand, hey, Thomas, are those retrofit? I believe yes. You would want to talk to Iris, and if that's something that is interested, if you're interested in, Thomas, we could find out. In fact, I'm going to put that down. Iris, IRIS, Windows retrofit, question mark. I don't see why they wouldn't be, but here's my gut tells me, Thomas, that if you're going to modify equipment in the field, you probably have to have a field evaluation. And in many cases, the covers have labeling, so it's not something that I can just ship because of the labeling requirements, etc. So, but we can definitely have that conversation. I will find out. In fact, maybe I'll get some of the cats from Iris to do a program with me. I think that's what I'm going to do. All right, so we put in there that you have to do your temperature differences. Accessible and necessary covers have to be removed prior to infrared thermography inspection to provide a clear line of sight to the equipment being scanned. Temperature differences between the area of concern and the reference area shall be documented. So what you want to do is, if you have a concern on a piece of equipment, like say you open this up and boom, you had the load main over here had looked like it was like there was a problem. you could take the thermography of that and then go to another lug that is a similar loading to see if there's a heat differences. And then if you keep track of your temperatures, you can see the trend over time. So data is your friend in a lot of this to help you understand the condition of maintenance for your equipment and when you might be experiencing a problem. Infrared thermography inspection shall be performed at nominal circuit loading. So you can't do this de-energized, right? You can't turn it off and do thermography. It needs to be pulling current. And where normal circuit loading is not feasible, circuit loading of not less than 40% of nominal circuit loading shall be permitted. So you can intentionally put some loads on there and it doesn't have to be hefty. And circuit loading characteristics shall be documented and retained for future use. So you're going to want to make sure that you keep your files online. So Thomas, I am going to reach out to the Iris people, and there is a gentleman that works there that I believe I talked to him once before, and I will I'm going to reach out to him, and we're going to do a program together. That would be kind of cool. Another thing that we did in 7.3, we have insulation resistance quality. This is your insulation resistance testing. And then in 7.2, you have your bolted bus connection, conductor terminations, and conductor connectors. This is your infrared. This is your thermal sensors, your contact resistance test, your torque verification. This is where you're going to have in torque verification, and I get this question a lot. They'll say, hey, can I verify torque? You know, can I re-torque something? You don't want to re-torque anything. It tells you that when using a calibrated torque wrench to confirm the torque of previously installed threaded hardware, the retightening value shall not exceed 90% of the manufacturer's specified initial torque value. And then where you don't have it, it gives you bolt diameters and torque pounds for recommendations for different types of bolts. And I believe what you're looking for is you don't want that bolt to move. So you don't want movement at that 90% number. All right. So in the chapter 7, we have the fundamental tests. And then in chapter 8, you have your field testing and test methods. This is when you are you're doing your field testing. So you have your risk assessments, your test category types. So this is, so here's what we're doing here. So you have what you'll see in chapter 9, the maintenance intervals, I believe chapter 9. You'll have, not in chapter 9. This will be in the individual products. So for example, panel boards. If I'm not mistaken, I might have, let me just look. Hold on. Yeah, right here. So, excuse me. So, you have an online standard test. You have online enhanced tests. You have offline standard tests and offline enhanced. Now, and that would be a 1 and a 1A. So online over here is online test is a 1. Online enhanced test is a 1A. Offline standard test is a 2. And an offline enhanced test is a 2A. Now, what this is telling you is the standard test is a standard test. You're going to be performing that. When you get down to like this is, I'll look at like individual products. That'll tell you what tests you have to perform and whether or not it's done online or offline. meaning if you have to establish an electrically safe work condition or not, right? So if it's online, it's energized. If it's offline, you've established an electrically safe work condition. But the enhanced tests don't mistakenly say optional. It's not optional. What kicks you into an enhanced test, and here's what it says, Category 1A, online enhanced. Online enhanced tests shall include certain testing procedures performed while the electrical equipment or device is connected to the source of supply and that are not typically performed in normal electrical maintenance activities and that provide additional diagnostic information. And there's annex material for that as well. So the way you want to use the enhanced tests, if you conduct, like let's say, for example, let's say you do a thermography test and a termination looks warmer than anything else. You might say you're going to perform, because you got data from one of the standard tests that sort of indicated there might be an issue, but there might not be. You may decide to do the enhanced test because of that abnormal test result, if that makes sense. So you have the online and you have offline enhanced tests that you perform when you see something that doesn't smell right or doesn't look right, okay? So, and it's here in Chapter 8 where that is defined. But you won't see a Category 1 online standard test or a Category 1A online enhanced test until you get down to these other chapters. So the way we laid the book out, which I love it. You have your previous chapters 1 through 10 are your general requirements. 7 is your fundamental test. 8 are your field testing and methods. All of those characteristics. And that's where you're going to have the details for each individual. These later chapters, if you want to know what the maintenance you need to perform on busway, it's right here in Chapter 14. If there's something you want to, if you want to perform maintenance on fuses, it's Chapter 16. Switches, Chapter 17. And if you go to Chapter 17, you're going to see tests separated into your periodic visual inspections that'll tell you, for example, on a switch. So just think about switches. There's visual inspections, cleaning, lubrication, mechanical servicing, and electrical testing. So 5 different groupings. And in each of those, for switches, if you look at visual inspections, you're going to have a task. You're going to have a task. You're going to have a 1 or a 2 in that column. Let's do this. I'm going to give you a little bit of the power of NFPA link. I'm going to use my mouse. Right, so you go to nfpa.org, you come up here to NFPA link, you sign in, you do that facial recognition, that voodoo that we do so well, click on 70B, come down here to, I'm gonna look at switches, which is Chapter 17. Passed it up. There's your switches, and what I'm doing now is I'm looking at your visual inspections. There we go. Let's just take a look at this table for giggles. You have the task. You're going to inspect the doors and latches for fit, dents, corrosion, and missing hardware. There's your 1 or 2 for 1,000 volts or less. So you can do this either as an online standard or an offline standard test, and it's required, and there are no notes. Now, I'm looking for, there's no 2A's over here. I'm going to look for an A. Lubrication, not in lubrication. Mechanical, nope. Here we go. Let's take a look at the electrical tests. Take a look at the electrical tests. All right, electrical tests. Expand. All right, so here you have performing thermography, and that is a 1A. So 1A tells me that it's an online enhanced test. If I go to chapter 7, if I go to chapter 8 and I look at testing category types, 1A is an online enhanced test. Perform infrared thermography for less than 1,000 volts. For greater than 1,000 volts, it's required on switches. 2, measure contact resistance. The reason I'm pausing is because if I look at maintenance intervals in chapter 9, chapter 9 has frequency of maintenance, and there's a very large table in there, in there. Man, my English is terrible. I got my Pittsburghese coming through. So switches tells you your visual inspections, your electrical testings are 60 months, 36 months, and 12 months. So chapter 9 gives you your maintenance intervals. This is how you navigate 70B. It's the way it's structured is a little you have to bounce around a little bit. So let's say, for example, you're going to look at switches. Chapter 17 for switches is going to give you your frequency of maintenance and what your periodic maintenance is. So 17.2 is going to tell you for switches that you're going to follow chapter 9 unless this chapter does something different than what's in chapter 9. And then you have your periodic maintenance procedures. You're going to have your, and pretty much all of the equipment is separated this way. Visual, let me go back. Visual, cleaning, mechanical, lubrication, and electrical. So visual, cleaning, lubrication, mechanical, electrical. Those are the 5 categories pretty much every piece of equipment is separated into. Your infrared thermography, when called out, you're going to go to chapter 7 to figure out how to do that thermography. If you have to verify torque, if you have to do any testing in the field for resistance, you're going to go to chapter 8 or 7. Okay? So chapter 7 and 8 are your general requirements for your fundamental tests is in 7. Chapter 8 are your field testing and test methods. So you're in chapter 17 for switches. If it tells you you need to do torque verification or thermography, you're going to go to chapter 7 and figure that out. If it tells you that you need to perform mechanical servicing and you want to know how often, then you go to chapter 9 for maintenance intervals. Unless the maintenance intervals are different in that chapter 17, which there aren't a difference. There's no difference. There's nothing in chapter 17 that says you have to do one more frequently than another. And then in chapter 17, For switches, it's going to tell you what are the tasks. So this could be the MOPs, which were asked earlier. What are your maintenance operation procedures for a switch? You're going to have, these are the tasks for mechanical servicing or your electrical testing. And in the case of the electrical testing, expand the table. And if you look at the different tasks that are required, you have your perform your infrared thermography, you have measure contact resistance, perform your insulation resistance testing, functional tests for switches with motor operators, verify, etc. Functional tests for switches with shunt trip, measure the resistance between line and load terminals. And you may say for less than 1,000 volts, you don't have to do that, but for greater than 1,000 volts, for medium voltage equipment, you do, right? So functional tests only for switches with shunt trip, you're going to have to, those are offline tests, mandatory. Functional tests for switches with motor operators, offline, mandatory. Perform insulation resistance, measure contact resistance. Both of those are offline and those are enhanced. Don't say optional. So you're going to be in one of these chapters for equipment, whether it be chapter 13 for panel boards and switchboards. And then if you are in panel boards and switchboards, what it should say, there it is, what it should say. Let's take a look at this. Well, I'll just tell you. So for example, visual inspections. For visual inspections, item 11 on the list of your tasks is for individual components. Remember, what is a panel board? Panel board's going to have, they could have a lot of, they could have surge in a panel board. You could have a breaker in a panel board. You could have a fusible switch in a panel board. You can have an energy management system in a panel board. It says for individual components, refer to the appropriate chapters of this standard. So if you have a circuit breaker in a panel board, the panel board chapter 13 is not going to tell you what to do with the circuit breaker. You have to go to chapter 15 for circuit breakers, low and medium voltage. And so in each of the chapters, say chapter 13 for panel boards, you're going to have visual inspections, cleaning, lubrication, mechanical servicing, and electrical testing. If you want to know how frequently to do that, go look at chapter 9. Chapter 9 tells you for panel boards. Let's go to chapter 9. We're going to go to the table. For frequency of maintenance, that's table 9.2.2. I'm going to expand the table. And let's look for panel boards. Panel boards, panel boards, panel boards. It's in alphabetical order. So panel boards, you have conditions 1 and 2 and 3. Now, if you want to understand what are the conditions, where do you go for that? Conditions are in chapter 9, maintenance intervals. If you scroll down, there's an equipment condition assessment, which will impact the frequency intervals. So 9.3 talks about the physical condition of the electrical equipment. 9.3.2 is the critical condition of the equipment. 9.3.3 is the operating environment condition. Each of those, you're going to give it a 1, 2, or 3, and then you have to determine an overall rating for that. So conditions 1, 2, and 3 will have different intervals. Condition 1 is like a new piece of equipment. Condition 2 is lightly used and weathered. Condition 3 is you've got issues, right? You've had reports of issues. You've got maybe open items that you need to fix. So a panel board for conditions 1, 2, and 3, I passed them up. Panel boards and switchboards, visual inspection every 60 months if it's in good condition 1, 36 months, so it's shorter time frame if it's condition 2, and annually if it's condition 3. So the worse the condition, the more frequent you need to be performing maintenance. So your maintenance intervals are 60, 36, and 12, pretty much across the board for visual, cleaning, lubrication, mechanical, and electrical testing for panel boards and switchboards. If we look at switches, let's look at switches. 60, 36, 12, visual, cleaning, lubrication, mechanical servicing, and electrical testing. 60, 36, and 12, conditions 1, 2, and 3. Now, physical condition, equipment physical condition 1. The equipment appears in like new condition. The enclosure is clean, free from moisture, intrusion, tight. In addition, in no unaddressed notifications from the continuous monitoring system. So if you have a continuous monitoring system, there haven't been any notifications. There are no active recommendations from a predictive technique, and your electrical maintenance program that's been performed has not identified any issues, and the previous maintenance schedule is on track. It's so if you were supposed to do things annually or every 5 years, you did one every 5 years. 9.3.2, this is your equipment physical condition number 2. Maintenance results deviate from the past results or have indicated more frequent maintenance in accordance with manufacturer's published data. The previous maintenance cycle has been revealed issues requiring the repair or replacement. So if you performed your maintenance and you identified, man, I'll tell you, this, this circuit breaker needs to be racked out and replaced. Well, now you've got a condition, you have equipment that you've had to replace a component. Maybe, I don't know, maybe it's a meter, maybe it's whatever that's inside. There have been notifications from a continuous monitoring system, or there are active recommendations from your predictive techniques. And then condition 3 says, look, the equipment missed its previous cycle. So if you were supposed to do something every 5 years, and here you are at 10 years and you didn't do it 5 years ago, you're in condition 3. You got to, you perform it more frequently. The previous 2 maintenance cycles have revealed issues. So if you had, over the last 2 cycles, you've had issues with a piece of equipment, then you're going to be performing the conditions, you're going to be performing maintenance more frequently because now you're into a condition 3. Active or unaddressed notifications from a continuous monitoring system, or there's urgent actions identified from a predictive techniques. So if you've identified that there are issues, so as you can see, condition 1, 2, and 3, things are getting worse. And you've got the 1 is the physical condition category. The second is the criticality. Now the criticality, I'll tell you what it used to say. The criticality used to relate to the business exposure, the cost of downtime. But the previous language, let me look at that. If I go to, let me do a search on the previous criticality. All right. Critical identification of critical equipment. I'm trying to find the language that I'll tell you. Man. Source, oh man. I'm looking at the previous edition to give you an example of what I mean and why it was so difficult. The failure of gas analysis equipment and interlocks in a drying oven or annealing furnace might allow the atmosphere and the possibility of explosion. The team should review the entire plant or each of its operating segments in detail, considering each unit of equipment as related to the entire operation and the effect of its loss on safety and production. So when you get into determination with production, what's a severe impact to production? I mean, if I have two lines and one line goes down and I don't know, I don't lose that much money and I can still produce from another line, then it's all relative. So it's hard to quantify the impact to production or financials. So we had a very difficult time in the criticality condition. And what we said was it's permitted to assign a condition 1 or a 2 where the failure of the equipment or systems will not endanger personnel. And then a criticality condition 3 where the failure of the equipment or system will endanger personnel. Well, some people would argue if it's going, if the condition of this can endanger personnel, then you should turn it off. So we had that the debate, and I think 9.3.2 is going to see some changes. And then you have the operating environment condition of assessment. This is, when you have equipment outdoors or in those environments, caustic environments, things of that nature. So you see how you navigate it. So if I go back down to 17 switches, you're going to go to your product chapter. You're going to look at the periodic maintenance procedures on what you're supposed to be doing. If you want to know how often you need to do it, you go to chapter 9. If you want to understand the condition, you go to chapter 9. If you want to know how to verify torque or do thermography, you go to chapter 7. If you have to perform tests in the field and do specific test methods, you go to chapter 8. And you wouldn't even include the requirement if you didn't have it in your plant. So that's a part of your electric maintenance program, which is chapter 4, general requirements. So you're going to pull together your maintenance plan. You're going to look at chapter 9, the frequencies. You're going to look at all of the equipment. You're going to create in your maintenance plan. You're going to have a plan for each type of equipment in your facility. You're going to go to the specific chapters. If it's a panel board, you're going to chapter 13. If it's busway, it's 14. You're going to look at the visual, the cleaning, the lubrication, the mechanical and electrical requirements from a maintenance perspective in that chapter. You're going to ascertain the condition of maintenance to determine the frequency, and that's going to be chapter 9. So you do bounce around a little bit. And you have to understand how they relate to each other. And oh, by the way, if you have manufacturer's instructions for that switch, you're going to follow those first. Hopefully that process makes sense. So that's I think an area that you've got to think about when you're talking about maintaining and performing maintenance. How do you navigate NFPA 70B the proper way is very important. How you get to your end result of creating a structured maintenance plan for each of those components in your facility. You're going to leverage manufacturer's instructions, manufacturer's maintenance recommendations. You're going to fill the gaps with NFPA 70B. You're going to understand the condition based on chapter 9. And based upon that condition, you're going to establish a frequency based on chapter 9. And then once you've established that for a piece of equipment, you're going to go to the specific chapter and you're going to understand for each piece of equipment, what are the visual inspections, what are the cleaning requirements, the lubrication requirements, the mechanical testing requirements, and electrical testing requirements. 5 areas for each piece of equipment. And the frequency will, again, be dependent upon the condition and what's in Chapter 9 or what's in the manufacturer's instructions. Make sense? I hope so. I hope that helps you understand how you navigate, and hopefully you have your copy or you have your membership in NFPA 70 in NFPA link, so you can take a look at the requirements that NFPA 70B has to offer, and you can use that to create your electrical maintenance program. And I'm telling you, if you don't know how to do that, Eaton can help you do that, right? You can leverage your relationship. If you're buying equipment, the time to get that done is right up front. So if you're buying new equipment, we can help you establish your maintenance plan for the new equipment. And oh, by the way, let's take a look at your existing facility. If you have an existing facility and you've never performed maintenance on it, and you have no idea of the risks that you are assuming, because if you've never performed maintenance, you are assuming risk. To mitigate those risks, you need to implement a program. We can help you do that. I think that it is manageable. And if you might say, I'm afraid of the cost, my answer to that would be, get the plan in place, figure out an implementation, spread your costs over a time period that is affordable to your organization. You don't have to boil the ocean on the first pass, but you at least have to have a plan in place. Recognize the areas of higher risk, and maybe you put procedures in place to address the additional risk to personnel for those areas of your facility and those pieces of equipment that have not been maintained properly over however many years. You're at least trying to address the risk, and you're cognizant of the vulnerabilities, and you'll have a plan that is then financed and budgeted for moving forward. Make sense? I hope it does. All right. I know by now you're probably asleep, and if you've hung in there till now, I really appreciate it. And I hope you got something out of this 1 hour and 48 minutes of pure 70B fun. All right, everybody, and who is ever left out there, I will be downloading this audio and putting it up on my podcast. So please take a look at that. Check out thomasdimitrovich.com. I'll put that in the chat. www.thomasdimitrovich.com. I'll have a link to my podcast out there, or you can go to www.tdunplugged.com. Subscribe to the YouTube channel. Hit the thumbs up. If you have to hit the thumbs down, make sure you hit it twice. And hopefully you got something out of today's discussion. I will, Thomas, reach out to our Iris people and see if we can't get a session together, maybe another live at 5, to talk about Iris windows, what we can and can't do, what can be retrofitted, what can't be retrofitted, how big do they come, how small do they come, how long and oblong do they come, does those, what about the angles of view, all of those different questions that we could possibly have. Hey, Nihad, you're still here. You are a man. You are the man. And so I will do that. I'm trying to think of anything else. I know I have I did a program with one of my engineering services individuals. It is on my YouTube channel. Scott and I both sit on code making or on NFPA 70B, and we did a session for maintenance. So that is also on my YouTube channel. You could check that out. And I'm trying to think of what else. So I'll try to do the iris scan, and then maybe, oh, you know what I'll start doing is I'll try to, maybe I'll do a session of just looking at manufacturer's instructions. That'd be kind of cool, and see what people say. All right. I have an action item. I'll reach out to my friends at Iris and see if we can't get a program together. Thanks, Nihad, Thomas, and anybody else out there who's hung in. And remember, this is available well after on my YouTube channel. It will always be up there. We can watch it, take a look at it. If you have questions, I am always here for you. Please feel free to pop a question, either through LinkedIn, Facebook, YouTube, Twitter. Go out to thomasdimitrovich.com and you'll see my email address out there. You can send me a note, all that jazz. All right. Thank you, everybody. Take care. I'm going to go upstairs now and relax. Thanks for hanging in there. Take care and stay safe. And please do what you can for electrical safety and stay healthy. We will see you hopefully next week at some point. See you Tuesday on IAEI News Live. Take care.